Welcome back, guys. So I'm going to have a quick look at the horizontal stretching of a graph, and we really need to read this one properly because it's the scale factor is it's not intuitive. It's the opposite of what you think would happen. So we're going to read this really carefully. So it is the bit that's just at the very top above the green box. It's the one on the right. It says y is equal to f of k times x inside the brackets, which means k is going to be some number that we're going to choose in a minute. And so it might be 3 or whatever. So maybe we're going to replace f of x with f of 3 of x. So replace all the x's with 3 of x, something like that. So the impact here is it gets, just for right now, I'm going to say skinnier or fatter. But also the way it's doing that is points are moving towards the y-axis and moving away from the x-axis. Just down at the very bottom, you can see it says if k is greater than 1, all the points move towards the x-axis. If k is between 0 and 1, all the points move away from the y-axis. So towards the y-axis, away from the y-axis. But this is the bit I want you to read and pay close attention to. So I'm going to read the top bit, and I'm going to focus on the bottom line. This is the top bit of the second paragraph, because we're not really dealing with the first one in this box anymore. We're dealing with the second one. So let's read that. It says the graph of y is equal to f of k of x in brackets. It's found by horizontally stretching the graph of y is equal to f of x with scale factor of 1 over k. And if you look at the rule, it says y is equal to f of k of x. There's no 1 over k in the rule. What they're trying to tell you is if you put a 2 where the k is meant to be, it's not going to look like an impact of 2. It's going to look like an impact of 1 over 2. So if you put a 2 where the k goes, you're going to actually make it half as far away from the y-axis as it used to be. So let me show that to you. We'll do one of each version, one towards, one away, and then you go from there. So I'll show you I've got one set up here. I want to do f of x equal to 2x squared plus 16x plus 22. This is what it is. I've changed the scale a little bit to make it nice to look at, but it'll be easy to identify if we're getting closer away or further away from the x-axis. I've chosen I might as well label it now. This is my turning point. I'm either going to try and get this point here to go closer to the y-axis or further away from the y-axis, and then the rest of the graph will kind of scale in the same way, like this point here, whatever that is. 0 in the y lines up with about negative 1.76, but whatever, if we scale it like it's half as far away from the y-axis as it used to be, that point should just end up half the distance. If we double the distance, that point will end up further away from that's the y-axis. So we're always trying to figure out, did it get closer to the y-axis or further away from the y-axis? So let's have a look at one. Let's go and get the whiteboard out. Okay, so I've got one set up here. So, do you know, I'm going to change this to 3 because I've got a 2 in the. Horizontal stretch scale factor of 3. I've got a 2 in the function there, and I don't want that to get confusing. So let's just read this. F of x equal to 2 of 3, f of x equal to 2x squared plus 16x plus 22. And what I want to do is a horizontal stretch of scale factor 3. Now, if the scale factor is 3, let's just do the quick working out here. The scale factor is 3. This is our note that we had before. Scale factor equals 3. Whoops. Equals 3. If you know how reciprocals work. This will be easier to spot, and if you don't, work the same both ways. So it's kind of like, shouldn't be too hard to spot. But our K value is equal to 1/3. So the value that we put in to this function here, if we want to make it 3 times further away, we can't put 3 in here. That'll have a different impact. We want 1/, this value. So let's go and do that. So we want 1/3 of x. A little therefore down the bottom. Okay, so if the scale factor was 3, the K value that we actually put in here is 1/3. It's always 1/, the scale factor. So let's do the working out. We're going to have to go like this. I'm going to separate the colors for sure this time so we get it all correct. So f of 1/3 of x is equal to 2 comes from the function. I'm going to replace all the blue bits with 1/3 of x. Oops. 1/3 x squared plus 16. 1 times 1/3 of x. Oh, I've changed my color too soon. There it is. Plus 22. Plus 22. Okay, now if you didn't learn your fractions well enough when you were a kid, this is where you're going to be exposed. But I'll talk to you. I'll speak through some of the fractions really quickly. But if this is difficult for you now and you're 10, you can expect a lot more of this. So you need to sort that out by getting a tutor or getting practice somehow. Right. 1/3 of x in brackets, the two's still the same, by the way. 1/3 of x in brackets means we square the third and we square the x. So 1/3 squared is, I'll just do it up here for you, or it might be behind my face. I'll do it down here for you. 1/3 times 1/3 is the top times the top, and the bottom times the bottom. So that's 1/9. Okay, it's 1/9 x squared. I've done that all in brackets now, so I remember to multiply everything by 2 later. But I have dealt with the squared. That's order of operations. I've dealt with the squared. That's fine. Okay, 16 times 1/3 is the same as 16 in the numerator spot and the third in the denominator spot multiplied by x plus 22. This is just 2. So if you multiply a whole number by fraction, you just get to multiply the numerators. Because the denominator is 1, that's still top times the top, bottom times the bottom. So I'm just going to put all these in. What I'm going to do here is leave it like that. That's perfect. Sorry, I thought I was doing something else, but I've just looked at it and it is in the format that we need, which is this format. I've got a number in front of the x's. I've got a number in front of the x squares. I've got a number in front of the x's. A number in front of, I've got a number at the end, and as always, this is a quadratic because a is some value. So if we've got this correct, 2/9 x squared, 2/9 x squared plus 16/3x plus 22 should be 3 times further away. So we followed the rule, and we ended up with this this quadratic here. But the point is, what we're checking is it 3 times away, and 3 times as far away from the y-axis as the first one. So let's go and have a look at that. 2/9 x squared plus 16/3x squared. Okay, so Desmos, type that in. So let's have a look here. 2/, let's call it g of x. It's a different function. g of x, some different function. Right, 2 over 9 x squared. What was it? Plus 16 over 3? Did I get that right? I'm going to have to go and have a look. Hang on. Let's go back to the whiteboard for a second. 16 over 3x plus 22. That's better. Okay. 16 over 3x plus 22. Right. So that is it there. Let's go. What color did I use? I used orange in my working out. So I'm going to use orange here. Let me know in the comments what's your favorite function color. Okay, so let's just have a think about this. Everything should be 3 times further away. So on the original, which is the blue function here, we've got a y-intercept of 0, 22, and this is 0 away from the y-axis. You can tell that because it's hitting the y-axis. So the orange should still be 0 away from the y-axis, and it is. So that's good. They should always hit the same point. The next thing I want to check is how far away the turning point is from the x-axis. Sorry, the y-axis, from the y-axis. So I'm kind of thinking about just this. I wonder if I can turn. Oh, I can turn the x-axis off. Yes, that's perfect. All right, that's good. There is still an x-axis, but for this, I don't need it. This is so much cleaner. I'm just trying to figure out how far away from the y-axis it is. So clearly this black vertical line here, this is the y-axis. So how far is this blue dot away from the y-axis? Well, it's 4 units away. -4, 10. It lines up. I can show you that it all lines up with y equals -10. Y is equal to -10. It's all lining up here. Let's just make this. So this is the line of y is equal to -10 just here. So you can see it lines up with y equals -10. But what we want is to know is how far away this point here is. And 3 times further away is -12, and still lining up with -10 in the x. But that is 3 times further away. I'll put the dot there because it makes me happy to see it. But the point is, we've done what we wanted to do. We wanted it 3 times further away. Make it orange, and we're done. There we go. We've got it 3 times further away than the original one. All right. Let me show you just the algebra for the other one. Let's just go back to the whiteboard. So that's like getting it further away from the y-axis. We want to also know how to get it closer to the y-axis. So I'm just gonna get rid of all this. Vertically stretch. Let's get rid of all of this. All of this. We don't need it anymore. Come on. Come on, let's go, let's go, let's go. Now, what we're going to do is we're going to make it twice as close as it used to be. Why is those little markings going? There we go. Right. I'm going to carry on. I'm going to do it in green because I haven't used green for a while. So here we go. Let's have a look at this. So now we want to get it like for a horizontal stretch factor of 1/2. And if the orange and green is upsetting your eyeballs, well, it's upsetting mine too, but I don't want to waste too much time here mucking around with colors. Okay, so we've got a scale factor of 1/2. That means every point along the function is closer. It's half as far away from the y-axis as the first one used to be. Now, the way we're going to figure this out is if scale factor is equal to 1/2. Oh, sorry. Yeah, well, actually, that's fine. That's fine. Scale factor is equal to 1/k. So if we go 1/k, is equal to the scale factor, which is 1/2, well then I hope it's obvious here. K must equal 2. You can see it, the K bit down here, and the 2. That must be true. So we're actually going to put in a 2. It's the same as what we did a moment ago in reverse. So 1/k, 1/2, K is equal to 2. Right. So let's just do this now. So we want y will be equal to f of 2x. And why am I having doubts about what I'm doing here? But I think I'm doing this right. Does that make sense to everyone? Yeah, it must be. Yes, this is right. All right. I've done a lot of videos lately. I'm getting confused. Okay, let's do it. I'm going to do the black separate. We'll do everything else in green. So it's super obvious, like usual. And right, so replacing all the blue x's with green 2x's. So that black 2, that's from the original function. We're going to go 2x instead of the blue x squared plus 16 times 2x plus 22. So same as usual, I've swapped all the blue x's out for green 2x's. Now we're going to do some algebra. 2. Now that's that black 2. We haven't done anything with it yet because we're doing to the power of next. That's the order of operations. 2x squared means we square the 2 and we square the x. So 2 squared is 4 and x squared is exactly that. It is x squared. That's that power dealt with. 16 times 2 is 32. So 16 times 2x is 32x plus 22. Right, we're almost done here. 2 times 4 is 8x squared plus 32x plus 22x. And this function here should be half as far away from the y-axis as the first one. So everything should be halved. So let's go back to 8x squared, 32, 8, 32, 22, 8, 32, 22, 8, 30. When I share this like this, I can't see my previous screen. But let's go back. Right. Let's turn off the further away one. Oh, actually, that was a helpful line, wasn't it? Let's leave that there. Okay. But what we do want is, let's do another one. Let's call this h of x. It's some new function. Oops, I don't need that label anymore. Right, it was 8x squared plus 32x plus 22, I believe. Okay, now let's change the color scheme here. I'd like to at least have, I made it green, didn't I? Okay, lovely. Now let's get a turning point, actually. It would be a nice point for us to know. -2, -10. -2, -10. That's perfect. That's exactly what we want, because that is half as far away from the y-axis as the first one was. So the first one's 4 away. Well, this one is, let's get rid of that line. It's annoying me now. This one is 2 units away. 4 units away, 2 units away. It's clearly half the distance. Now, I do just want to emphasize this one more time. The way we got it half as far away was by putting a 2 in there, not putting a half in there. We put a 2 in the 2x, and if you remember the previous part, we put a 3 in. We put a third in to make it 3 times as large. Anyway, that is how to horizontally stretch. Thanks for watching. Leave a comment, like and subscribe, and I'll hit you up in the next video with more Mr. Steve Maths. Anytime going a bit crazy, like sitting in front of a computer doing maths for you guys. But anyway, it's starting to sound like probably no one. Maybe I'll watch some PewDiePie videos soon and just get some tips, you know, maybe just like liven things up a bit. Okay, yo.